Dear friends, a very happy morning to all. On behalf of Francis Xavier Engineering College, I would like to extend a very warm welcome to every one of you who is watching this webinar. We thank you all for taking time out of your schedule and joining us with this event. I am Ram Kumar, Assistant Professor in the Department of Mechanical Engineering. It is a great pleasure in sharing a few words about our college and our department. Francis Xavier Engineering College is located at Tirunelveli city and it was established in the year 2000. FX Engineering College comes under the SCAD group of institutions and our institution has been offered autonomous status in the year 2019. We offer 6 UG programs, 10 PG programs and research centers. Our college has achieved many awards. Among all, I would like to list a few to your knowledge. We got Gold category for Industry Linked Technical Institute, which was awarded by AICTE CII survey. In Chronicle Engineering College survey, we achieved 3rd position among 19 engineering colleges in India. In Times Best Engineering College survey, our college has achieved 15th rank in Tamil Nadu and 108th rank in India. Apart from all, we got ICT Academy, Tamil Nadu Academic Partner Excellence Award in the year 2017. Regarding the Department of Mechanical Engineering, it is the largest department on the campus with 600 plus students, 30 plus faculty members and with good infrastructure facilities. We offer BE in Mechanical Engineering and ME in Industry Safety Engineering. The UG program is accredited by the National Board of Accreditation. We have FANUC Center of Excellence for CNC Center, BMW and Hyundai supported mechanical labs. Our department has signed many MOU with the leading manufacturing and service industries. Apart from regular academic activities, our students have been trained and imparted with various skill training programs and value-added courses. Our students are actively participating in many technical competitions, winning prizes and add glories to our department. We also offer international certified program on computer-aided design and non-destructive testings. We have also organized many international conferences, workshops and funded seminars. Today, we are organizing this online webinar. I hope the session will be more useful for all of us. On the final note, I welcome all the viewers for the session and hope we will have a productive time. Thank you all.
Good morning to all. With a special excitement, I am pleased to introduce our speaker for today's webinar, Mr. Sendhilathan Pichandi, Manager, Research and Development, Siemens Gamesa Renewable Energy, Bangalore. Mr. Sendhilathan have completed Diploma in Mechanical Engineering in the year 1999. After completion of Diploma, he have joined TVS Hosur as well as he has done AME parallelly. And he was the youngest Indian to be awarded as an Associate Member of Institution of Engineers at the age of 24. And he continues his service at TVS Hosur. To improve his position in the industry, he have joined ME CAD/CAM at Alagappa College of Technology, Karaikudi from the year 2005 to 2007. And again, he have joined TVS Hosur as a design engineer in research and development. In the year 2008, he have joined Vestas Technology as a lead engineer in research and development till the year 2010. From 2010, he have joined ZF Wind Power Coimbatore as a manager for research and development till the year 2019. So at present he was working at Siemens Gamesa Renewable Energy not only as a manager for research and development but also he was a global expert being a solution provider for all the gearbox related issues in wind turbines. Mr. Sendhilathan has expertise in gear technology and experience in design, gear manufacturing and testing and product development. He has knowledge of geometric dimensioning and tolerance, tolerance analysis, design for manufacture, design for assembly, and failure mode and effect analysis. He was a trained Six Sigma professional at Green Belt level and a Yellow Belt in design for Six Sigma. He was well experienced with the TQM process in design and manufacturing, and is also conversant with international standards like DIN and ISO. And we are very happy to have him as a speaker for today's webinar. Thank you.
Welcome to all. First of all, I would like to thank you, Professor Satish Kumar and management of Francis Xavier Engineering College for providing me this opportunity. I'm Sandil Nathan. I'm working in Siemens Gamesa Renewable Energy in Bangalore. I'm expertised in wind turbine gear technology. Today, this session is about understanding of the fundamentals of wind turbine gearbox. Actually, this is a very vast topic and in a short time, but I assure you that you will get some knowledge about the wind turbine, where the gearbox is located, some fundamentals of gearbox, what are the main parts on that, and challenges in this gearbox industry. In this webinar, actually, we are going to go through the overview of global and Indian wind energy, overview of main components in the wind turbines, what are the main parts of drivetrain where our gearbox is located, fundamentals of gearbox, and what are the challenges in this gearbox industry. Due to confidentiality issues, this is actually my personal presentation actually, so no company related the product information or pictures, relevant information are shared in this webinar. It is mainly intended to create some general understanding and to create awareness to the engineering students, so company templates also not used. Yeah, this is for your information. Coming to the wind energy overview, you can see the first chart. It's a global wind power installed capacity. You can see the continuous. There is a continuous demand of increasing demand of the wind power from the 96 to 2018. Even in 2019, yeah, in 2018 it is 591 gigawatts. 1 gigawatts is 1000 megawatts, so you can calculate 2019 it is almost 650 gigawatts globally, the installed capacity. Coming to the uh, coming to the second chart, it is the country wise, the on the installed capacity country wise, almost China is leading in the world with 36.3 percentage of total installed capacity. Second is United States with 16.2 percentage. Our country India is on the fourth place with 5.8 percentage of uh, renewable energy. If we see the market, actually until 2010, Europe and North America are the main markets in the world. But since 2010, the Asian countries also becoming a huge market for wind energy, especially China and India. All this within this 10 years, China became the number one in total installed capacity, as shown in the second chart. In India, how the renewable energy is distributed. It is given in the third chart. We have a lot of resources for renewable energy, like not alone wind. There are a lot of solar power plant. Recently, also uh, inaugurated a huge 750 megawatts solar power plant. There are a lot of being in from Tirunelveli, lot of hydropower stations also. People may have seen. There are hydropower station sources available, biomass power available, and a small amount of waste to power renewable energy. So out of this total renewable energy in India, 45% is coming from the wind power. In March 2020, if we see the 35.86% of Indian electricity generating capacity is from renewable energy. That much huge. Um, it is still, it is actually the growth is going on. Uh, so we are not newly inaugurating the thermal power plants. You may have seen the Thuthukudi thermal power plant. Further, it is also almost 1 gigawatts plant. But further, we are mainly focusing on it is a very green energy. So the entire global focus on going completely for renewable energy. Some European countries like Denmark, it is almost 50% of Denmark power is coming from the wind energy. So some other countries, like Ireland, it is completely renewable energy is working. There is no thermal or other resources. So like that, it is a highly growing sector. Coming to the main points, main components of geared type wind turbines. Here I mentioned actually geared type wind turbines because the geared type wind turbine means there will be gearbox. There are without gearbox also turbines are available. That is called direct drive wind turbines. So, but the generator size will be big. Um, on that, there are some advantages and drawbacks are there between direct drive and geared type. But most of the installed turbines in the field or in the wind farms are the geared type wind turbines. It is a traditional method and it's well proven method. So still people are mostly the percentage wise, the most percentage will be on geared type wind turbines. So coming to the main components, first component from long side, you can see the tower. Okay, the tower carries the entire rotating parts like blades, hub, and carrying the big nozzle. This box is called the nozzle, where we will see the cross-sectional view here next to. So where all the drivetrain components are located, it carries the complete weight of the uh, all the entire system of wind turbine, and to keep the all parts at the required height, so that the wind flows at the appropriate height. And all the three, there are three blades. There are other blade, two blade configuration, everything people have tried, but finally the three blade configuration is the ideal one, and most of the turbines in the world follows the three bladed concept. The blades are connected to the hub, this component actually. The hub is connected to the main shaft. The main shaft is coupled to the gearbox. This is the part we are focusing. The gearbox is coupled to the generator, where the power will be generated, and there will be lot of control and power electronic system to proper functioning of the entire turbine. Yeah, other systems are there like pitch system to twist the blade based on the wind speed, and yaw system will be there. My entire to turn this entire nozzle. This complete box is called a nozzle. To turn this nozzle against the wind direction. Wind direction will be keep on changing. Now morning it will flow in some direction. Then after 3-4 hours it will change the direction. So we need to complete rotate this complete unit towards the wind direction. So there will be some sensors also at the top of the box. There will be wind direction anemometer to speed sensing of wind, and also for wind direction sensing. So this will give signal to this yaw system, so that it will rotate the complete the entire unit towards the which is towards the wind direction. Yeah, these are the main components. As the title is mentioned, windmill, I would like to explain actually windmill versus wind turbine. Both are actually a different one. But I agree, in India, the both terms are used interchangeably. But windmill was made to grind grains, and also to generate some, like some places they are using for pumping water also. Like whatever in the right side picture, this is actually a windmill, but wind turbine, it produces electricity. Windmill actually converts the kinetic, both converts actually based on work, wind only it works. Windmill converts kinetic energy of the wind to mechanical energy actually. Like like our rice mill. Actually, we are rice mill, they are using electrical motor, but here at that time, in the remote places, they will not have any electricity. So to grind grains and other purposes, they use the wind, so that the kinetic energy to record mechanical rotation, that energy even for textile they were using. So for in case of wind turbine, they are using the same kinetic energy of the wind to electrical energy. In India, in fact, in my knowledge, we don't have any windmills. Actually, we have only wind turbines. But somehow the term from the earlier days, it came, and uh, many places still it is used. Actually, windmill is different, wind turbine is different. We are focusing only on wind turbine. Coming to the gearbox, gears is one of the very oldest element in the mechanical. Even it is evident that it is used in BC history itself. But the gears become popular after the invention of gear generation process. The gear generation process means gear hobbing, gear shaping operation. This kind of this created the gear production like a mass production concept. Before that, like only milling, gear milling, gear planing, like that kind of operation, which is not accurate enough. It is very time consuming. You need to index each teeth. After one teeth milling, you need to index it like that. So it was not a mass production concept. So the first gear hobbing was invented in 1835 by British inventor Whitworth. After that, later, lot of development happened. Like yeah, it is a conventional machine. Then NC controlled machine came. Then CNC machine came. Then when during this development, lot of quality improvement also happened in the manufacturing field. So you can see the bottom pictures. So this is actually inside that windmill, whatever I have shown the last picture. It is made of actually wood. So the big disc will be like from the wind. This shaft will rotate. This will drive the axle with the proportional some kind of rod kind of structure. So it will drive that, so that this shaft, this rotation will be used for their required either textile or to grain grains or any other purposes. Now, from this stage to the last picture is the current status. Actually, we can see the how much we evolved in this gear technology. Coming to the role of gearbox in wind turbine. Now we are going to see the why gearbox is used in wind turbine. It is simple actually. You have seen from outside the blades are rotating very slowly. You can count it actually by seeing by keeping your stopwatch. You can count in 1 minute how many revolutions it is happening. It is very slow actually. So maximum like 5 to 15 rpm. Many 10 to 15 rpm will be normal. Some turbines based on the wind speed actually. It is 5 to 15 rpm. But this RPM is not sufficient to generate electric power, because generator needs certain speed to achieve to produce electric power. Uh, so the to rotate the generator armature at 1500 RPM or 1000 to 1800 RPM, this depends on how many number of poles in the generator, what is the frequency, whether 50 hertz or 60 hertz. In US, it is 60 hertz. We are using 50 hertz frequency. So there are a lot of differences on the generator. Based on that, 1000 to 1800 RPM, the generator needs to be generator shaft, actually armature shaft, to be rotated to generate electricity. So gearbox needs to be a multiplier of this speed. So blade is rotating. You know the mass of the blade, how much almost. For example, the 2 megawatts turbines blade, one blade is almost 7 to 7.5 ton of weight. So you can see how much 3 blade weight will be. So that much weight it needs to carry. So if we are rotating at that speed, 1500 rpm means It is impossible to hold it that much weight. We cannot hold it. So it will be rotating at a very slow speed, and there will be a transformer like uh, multiplier to increase the speed to give the required speed to the generator shaft. So this multiplier role is our gearbox. Not alone the speed multiplication, it is not a freeload application. Freeload application means it is not a, like in textile, if you see the shafts, it will run very fast because there is no load. It is just a spinning yarn or this kind of, there is no heavy load is involved. But in this case, it is very, very heavy loads. So it needs to, not alone the RPM is coming, the torque also coming. When the torque and RPM is coming, yeah, default it is a power. So to transfer power from the low speed shaft to high speed generator, actually here high torque is coming. Here when the speed is increasing, actually 100 times, example, it is increasing means 100 times there will be a reduction of torque level, because power is same. When there is a continuous transfer of movement, the power will be same on all over the places. So there will be, if n is increasing, t will be decreasing. n rpm is increasing means torque will be decreasing. That is the concept. So main purpose of gearbox is to multiply the speed and to transfer power from the low speed rotating blades to the high speed rotating generator. Normally, the wind turbine gearbox capacity will be the power 1500 to 6000 kilowatts. It is 1.5 megawatts to 6 megawatts. In terms of 1 megawatt is 1000 kilowatts. Maximum we will see it is given in terms of megawatts. The gearbox ratio is 46 to 120. Here I would like to mention in India, up to now, less than 3 megawatts turbine only installed. But in just a week before, in from Siemens Gamesa, turbine with the capacity of 3.4 megawatts. You can see in the website a lot of pictures, and you can get into the Siemens Gamesa's websites also to understand the turbine related details. It will be very interesting. 3.4 megawatts is India's current largest wind turbine. Even blades are like 75-meter length. It's a huge one. So it will be an interesting one to read that. And input torque at the main shaft ranges from 500 to 3500 kilonewton meter, and weight of one gearbox will be from 15 to 85 tons. You can assume, actually, like 2 megawatts turbine gearbox will be around 17-18 tons. So 6 megawatts maybe this much weight will be there. Main components of can tell subsystem, because subsystems of gearbox, gears and shafts. It is almost any gearbox, not alone wind turbine gearbox. If you see any gearbox, it will be categorized into subsystems like gears and shafts. So gears and shafts will be supported by bearings. So bearings, to hold the bearings, we need the housing for ensuring proper functioning of gears and shafts and bearings. You need proper lubrication system, and certainly there will be a lot of accessories like sensors, like particle counter. I will explain later. So in gears and shafts, there are a lot of things like planetary gears or parallel gears. It's splines, keys and keyways, mechanical pump gears. In bearings, cylindrical roller bearing, taper roller bearings. There are different type of bearings, actually, based on the application requirement. It is used wherever the axial load is coming, thrust bearings, or some flexibility is needed, like misalignments, spherical roller bearings. And in housing to hold, which is holding the bearings, which act as an enclosure for the complete system or complete parts inside the gearbox. So these parts, Tarkam upper and lower housing, this bearing covers. This is specific to the because Tarkam is specific to the wind turbine application and lubrication. In the lubrication system, mainly the lubricant, that is oil, what oil it is used. Um, it's there is no separate sump is maintained. The lubrication will be kept in the housing itself. It will be inside. Almost 440 liters of oil will be there in the gearbox. So there will be pumps, electrical and mechanical pumps will be there. A lot of filters to clean the oil, manifolds and valves, like any other hydraulic this lubrication circuits. There will be heaters, coolers, and pipings and hoses. Yeah. Going to the next slide. So gears. How the gears are configured in the wind turbine gearboxes. You see that the first is LS stage, that is a low speed stage. Three stages actually: low speed stage, intermediate speed stage, high speed stage, like that. Low speed stage, it is a planetary gear set. The second stage, intermediate speed stage, is a parallel one, and high speed stage is also a parallel stage. The planetary or epicyclic in your academy, I know both the terms are used actually. The input from the blade is transferred to the maybe picture. Okay, input from the blade is transferred to the gear set, to the planetary via the planet carrier. Planet carrier is invisible here. The planet carrier supports the planet wheel, and at the center there will be a sun gear, and there is a ring gear which is at the outside, and the sun gear is connected to the low speed wheel, and low speed wheel is having mesh with the pinion in intermediate speed shaft, that is IS shaft, and in the same shaft there is a intermediate speed wheel which is connected to the pinion in output shaft. So this is a most gearbox have the configuration in when the capacity or when the power like 4 megawatts, 5 megawatts, 6 megawatts, when it is increasing, there is like here one planetary, two parallel stages there. There are recently, when the capacity is increasing, they are going with the two planetary stages and one parallel stages, like that also going on. But most of the gearboxes follows this configuration. We three stages. If we see the total ratio can be done in one stage itself, correct? Suppose you have seen the ratio is 46 to 120. Assume 120 is ratio requirement. So to achieve 120 in one stage, is it possible to achieve? 120 to be achieved in one stage means, compared to the pinion, the wheel should be 120 times. So it will be too huge to manufacture or to assemble anything actually. So it is impossible. So the standards, and it is a best practice to have the ratio in one stage within 6. Um, this formula gives total gearbox ratio is requirement is like 89. Permissible speed ratio per stage is 6. Then by considering the logarithmic ratio, the number of stages coming to 3. By providing this 6 ratio, we will have good strength. It will be a compact one. It will be having more strength. It will have good contact ratio. It will give good performance like efficiency and noise conditions. That's why this number is arrived. And universally it is followed by all gear manufacturers. In all the most of the wind turbines, I will say that the ring gear is a fixed part. The peculiar concept of planetary gear train is actually we can achieve in a simple in one planetary. We can achieve three different kind of ratios by which one you are rotating, which one you are keeping fixed. In this case, if you see the ring gear is a fixed one, and planet carrier is rotating. Planet carrier supports the planet wheel, and sun gear is a driven part, which is the output. So this the ratio is calculated by 1 plus ZR by ZS. ZS normally used for number of teeth in gear domain actually. It is a standard description for number of teeth. And this is a formula for planetary gear ratio plus number of teeth is of ring gear. For example, 87 teeth, sun gear it is 18 teeth. Then the total ratio is 5.83. What it means? So if the planet carrier, which is connected to the blade, that hub, which if it is rotating 10 RPM, assume that 10 RPM planet carrier is rotating. So when the planet carrier is rotating, then planet will rotate. The ring gear is fixed. So on one side it is driven by ring gear. It revolves around that, and it drives the sun gear to rotate. So the sun gear will rotate this many times the input RPM. Suppose 10 RPM is given, sun will rotate 5.83 into 10. So 58.3 RPM, the sun gear will rotate. That is the concept. Similarly, considering the other parallel stages. So this second stage, the intermediate speed stage, the wheel number of teeth is 74 and pinion number of teeth is 18. Let me explain actually. I am using gears, wheel, pinion. The terms actually, all the two, three elements are called gears. When in a gear set, whatever more number of teeth, surely in a gear set, one will be bigger, one will be smaller. So whatever the bigger one is called wheel and smaller one is called a pinion. And all the two, three elements, whether it is a pinion or wheel, it is a gear. But bigger one is wheel. So this wheel 74 teeth, it drives the pinion having 18 teeth. So this ratio how much? Directly it is a parallel stage, so it is simple, the ratio of number of teeth. So 74 by 18, 4.11 is a ratio. This stage 3, so this wheel mounted on the same shaft, it is a 92 teeth, and the pinion is 25 teeth. So the ratio is 3.68. Considering the all stages, so it is very simple. You can just multiply the ratios of all stages, stage 1 into stage 2 into stage 3. It is around 88.18. If the requirement is like 89 in the example earlier, it is given, there will be, we cannot achieve the exact ratios. The number of teeth, we need to keep it round. We cannot have 87.1 or 87.2 teeth. So we need to keep this exact whole number of teeth. So the ratio, we cannot have the exact number. There will be plus or minus like 0.2, 0.3% of tolerance will be given from the customers. So it is a 88.18 ratio is coming. So overall ratio. That means in the as example I told, 10 RPM is given, and the input, the planet carrier is or blade is rotating at 10 RPM. The output shaft will be now 880 RPM. So 88.18, you need to just multiply the ratio by 10. So 880 RPM will be the output shaft. This shaft is connected to the generator. So generator will rotate at 880 RPM. But why the planetary stage is used, especially for the first stage? We know that actually the first stage takes a high torque input from the blades. So in a simple gear set, like this actually, in a simple gear set, the ratio will be the contact ratio. It is just one mesh, so the contact ratio will be too less. So entire the loads from the blades needs to be taken by this gear mesh, which is quite impossible. Then it is possible, but you need to make this teeth too big enough so that just these two teeth bear the entire load. In the other case, in planetary carrier, in planetary drive, in this case actually three planets. So you can see actually three positions the mesh is happening. So the torque is distributed with the three planets. If you are having 4 or 6 planets, so 6 places the distribution will happen. What's the benefit actually? So you can go for the same torque, you can go for smaller size of the tooth. So like a heavier person taking one load, but the same load cannot be if by small people, 2 3 people can take the same load, correct? Similar concept only. Like you can go for a smaller gears, but 2 3 like even 6 planet wheel concept also available. So you can go for a very compact one. The advantage is manufacturing. So you can, if it is too big, it's a manufacturing, transportation, in case of service, everything it is complicated. But the it is not only the gearbox size will increase. If you are going very big means gearbox size will increase. Gearbox is going to be placed at the top of the tower. Then the entire nozzle which is enclosing the complete gearbox, everything will be increased. So it will not end only with the gearbox. It will result in a lot of other parts also. So making a compact gearbox is a ideal solution. For that, the planetary stage is available in all the wind turbine gearboxes. Coming to the bearings, like in the first stage, it is supported. First stage means this one, planetary stage. It is supported normally by cylindrical roller bearing and taper roller bearing on both sides. Actually, any shaft needs to be supported by both sides. So this pink color or something. It is normally on both sides. It will be supported by cylindrical or taper roller bearing. In this case, it is cylindrical roller bearing, and this looks ball bearing in this view. In the planets, so you can see the planets. It is supported by 4 cylindrical roller bearing, but most of the cases in wind turbines will be taper roller bearings only, because in all turbines, why I am telling taper roller bearing is in all turbines the helical gears are used. So helical gears will have the good strength, good noise performances related to the noise. It can be compacted for the same capacity, for the same megawatts capacity. You can make a compact gearbox with helical gears, but the drawbacks, you may have already learned that drawbacks in helical gear is axial forces. So you need to hold it. Cylindrical bearing, cylindrical roller bearing cannot hold the axial forces, so you need to go for taper roller bearings. So this is a sun shaft. Sun shaft is connected to the intermediate parallel stage. There is a big wheel, and this all these three shafts are supported on one side by cylindrical roller bearing, on the other side by taper roller bearing sets. So that why there is a, instead of single taper roller bearing, why two bearings are used. That is because whenever there is a reverse rotation, sometimes in the opposite direction also, then because of helix, in a normal rotation, the force will be, axial force will be in this direction, means in reverse rotation, it can go in the opposite direction. So at that time, a failure can happen. So because of that, in all the shafts, there will be two taper roller bearing sets. Coming to the lubrication system, why the lubricant or lubrication is used? Mainly, it reduces friction. Whenever there is a movement of parts like gear meshes is happening and bearing rotations are happening, it produces a lot of heat. So to reduce heat, to reduce friction between the moving parts, so you need to have certain lubrication film thickness, and it reduces wear between the moving parts, and also lot of temperature, a lot of heat will be generated due to these rotations. So we need to dissipate that heat, and this oil will act as a protection layer. It will protect the corrosion and oxidation of the parts, and also it ensures the smooth operation of the equipment. Whatever the wear particles on the gear teeth or bearings will be taken away, because the lubrication here, it is a forced lubrication in most of the locations. In some area, yeah, dip lubrication also available, but in most of the area, forced lubrication. Anyhow, forced or dipped, it will carry away the wear particle, whatever the micron level wear will be there. So it will not stay there. Immediately it will be taken away by the lubrication system or lubricant, and it will be circulated again through filter. So there it will get filtered. So the oil will be always clean, and the components also will be clean. This is the main functions of the lubrication. The important parts like electrical pump, mechanical, there will be two pumps. Earlier I was mentioning in the subsystem presentation that there will be two pumps, electrical pump. In case of grid failure, in case of there is no electricity, but turbine started rotating, you need the parts cannot, if the bearings and the gears are rotated for some time without any oil, it will cease. So you need always some kind of amount of oil, at least minimum oil condition is required. That's why a mechanical pump also provided. This mechanical pump will be driven by the gear train, like it is connected to the earlier the parallel stages I was mentioning. One of the wheel, it will be connected, so that once a gearbox started rotating, this pump will started operating, so that it will supply a minimum amount of oil. Then once the electricity comes, then electrical pump will be switched on, and it will start pumping more oil. And yeah, important parts means a lot of pipings to directly spray the oil on the secured locations, like on the gear meshing area, on the bearings area. So a lot of pipings will be there. Hoses to connect from the reservoir at the bottom of the housing to the motor filter and to the manifold. And there will be filters will be there, online and offline filters, and there will be like other any circuits, lubrication or hydraulic circuits, there will be valves and coolers. The all the system like gears and bearings, mainly bearings will operate optimum condition at a certain temperature range. Actually, we should not operate the bearings beyond 80 degree. Up to 90 degree also it is fine, but beyond that it should not so we need to cool the oil. So the it will when the oil is sprayed over the part, it will take away the heat, but that oil again will go to the cooler and get cooled, and it will get sprayed over the moving parts. So it depends on the temperature or total heat produced, where the heat is produced based on the losses on the gears. Mainly heat is produced based on the bearing or gear losses. The there will be frictional losses. This friction is converted into heat. So this heat is carried away by the coolers. So how, based on the how much losses on the gears and bearings, that much heat is produced, that much amount of coolers will be required. And heaters will be there at the bottom of the gearbox. There will be 3 or 4 heaters. Why it is needed is actually we are not putting the gearbox or turbine in always very hot condition. It will be placed wherever, even in Arctic side also the turbines are running. You can see in the lot of Google picture, very nice pictures will be there. You cannot see the turbine; it is completely covered by the snow, and so it is that much temperature it should work. So there will be a lot of heaters inside, so that the oil should not freeze. Correct? Oil need everything. All systems should be heated enough so that oil flow should be there. It should, the greasy condition. Very cold, oil will become little bit greasy kind of thing. Viscosity will increase heavily as it is a temperature dependent. It should flow. So there will be heater to heat the oil, and breathers. Breathers means any gearbox, big gearboxes especially need some breathers. When your gearbox is running, lot of some this oil evaporation also will happen. It needs to go out. Some fumes will be there, so it needs to go out, and also it needs to take some fresh air but less contaminated air. So there will be some filtered kind of arrangement in the breather. So when it should take the atmospheric air directly, if it takes a lot of moisture also will come. When the air we are putting a lot of offshore turbines. Offshore turbine means it is putting on the sea also. So sea means a lot of moisture content will be there in the air. So if it enters inside, so the parts will get rusted. So the breather will control it, the input air condition, whatever coming inside the gearbox. So oil cleanliness level. If you see the, it is mainly I am giving to understand the how much cleanliness is required in wind turbine gearbox oil. Um, like there are standards, the uh, approval for the wind turbine gearboxes, that greater than 4 micron, this many number of particles only allowed. Greater than 6 microns, only this many number of particles allowed. Greater than 14 micron, this many number of particles allowed. So like that. So our oil should have that much cleanliness, otherwise we cannot get certificate, and a lot of other problems also will be coming. Condition monitoring, there will be lot of sensors in the gearbox, like temperature sensors at bearing locations, and accelerometers, which is for vibration measurement around the gearbox to measure. And oil particle counter. Oil particle means it is actually the earlier I was mentioning that wear particles will be taken away by the whatever the wear particles will be taken away by the lubrication oil. So this oil will be go through the filter, and this oil with the particles will be passed through this particle counter. So in the particle counter, it will sense based on the particle size, and this one, and it will get detected. Okay, more whether it is increasing, sudden increase of particles or not, what kind of particle size, like that. So it is good in detecting the failures at an early stage without disassembly of the gearbox. So that is a main thing. It is a preventive maintenance kind of approach, and the sensor signals are captured by the SCADA system. It is a supervisory control and data acquisition system. This system is a nerve center of the entire turbine. So it is not only the gearbox, the entire turbine, like pitching, or from the generator, from pitch, from all the signals from wind speed sensors to all signals will be taken away, or the signals are connected to the SCADA system. We can monitor the behavior of the turbine just by sitting on our computer wherever you are, even from your home also you can see, okay, this turbine suddenly that bearing temperature is increasing, some problem is going on, some turbine is stopped because of heavy wind. Like that you can understand by sitting from your home. Almost Most of the turbines are connected with the SCADA system. It records a signal on a 10-minute basis, so that the engineers, it helps to determine any corrective action to be taken or not from our side, or some it will automatically run, or okay, it is completely stopped because of some breakage, means okay, some we need to go there and attend. So we cannot suddenly the blades are not rotating, we need to go like that. No, we it will give signal to your computer. So from by seeing in your computer, you can go and check the wind turbine. So SCADA system helps a lot on that. And as the wind turbines are located very remotely, um, if you see our country, okay, everywhere there is people are there, so no problem. But in US, and it's a very vast area, so like Arctic also, it is very remote. So at that time, we cannot go and see each turbine directly. We can also have one operator maximum. He can climb only 2 to 3 towers every day. Beyond that, he cannot climb. You may have seen the tower height, so he cannot every day go and see that. So this system helps to reduces the number of visits. It helps to do preventive maintenance of turbines. Challenges. Yeah, if we see the turbine capacity, it is continuously it is increasing year on year. Even in 2016, it is 8 megawatts. Yeah, I don't know it is commercially available or not. I'm not sure. Even the latest, the highest megawatts is the proposal is given from Siemens Gamesa. It is 14 megawatts. So they are starting working on design. 14 megawatts means you can assume our in India now 3.4 megawatts only recently launched. So you can see the difference. It's a huge turbine. So it is a continuous increase in wind turbine capacity. So we need to keep on updating our gearbox design. So you need to there are a lot of more gearbox size means more weight also coming into your manufacturing capacity, your lot of complications in the manufacturing. So very flexible and highly scalable product platform. Earlier we design for each gearbox requirement for each turbine, unique gearbox is each turbine platform, or like 2.3 megawatts. So, okay, this gearbox we will design like that. Unique gearbox is designed, but it will take lot of time. Now, in a very competitive atmosphere, we need to give it very fast. So, we will design a standard product platform. So, it can which can be used. Okay, input target 2000 to 2500 kilonewton meter. We can select this planetary stage. We can directly use it like that. So different modular concept is came in wind turbines recently in all manufacturer accommodating it. And high torque density, that means you need to deliver that much required torque, but the size should be less. The volume of the gearbox should be less. That's a requirement. The weight of the gearbox should be less. So for the given torque, so that is a high torque density. And noise and vibration. Once upon a time, this initially the requirement is a little bit less, I will tell, because it is working remotely and it is at the very top height. So compared to the automobile, this noise and vibration was given lesser importance very earlier. But now it is the customers are very conscious about that, and more focus is given on the noise and vibration of the gearbox and high reliability requirement. Normally, I will tell that 20 years lifetime the gearbox is designed. So, and people are asking beyond that also. sometimes they are asking for high reliability and cost competitive. In them, let me explain. In the manufacturing perspective, if we see the size of the gears, it is a huge size. Actually, there are some constraints in this kind of increasing capacity of the gears, especially the manufacturing. If we see the size of the gears are too much, current industry actually supported by only few suppliers in the market. Heat treatment process, you may have understood, doing such a huge components heat treatment is very difficult. Case carburizing and nitriding is widely used in this, and steel quality, very high quality is maintained. You know, the production, the wind turbine gears are very much equal to the aeroplane gears. It is used. The quality level is that much equivalent, and the DIN 6 quality gear finishing is used in flights, means the same quality is maintained in wind turbine gears also. That much high quality. The steel quality plays. Steel quality means it is how much inclusions or the particles, the non-ferrous materials involved in the steels. So too many checkpoints are there. It needs to pass to have better performance and life standpoint, and casting and machining, grinding, because of this size constraint, huge castings, huge forgings, and stringent quality requirements. So validation means actually every gearbox manufacturer will have a separate testing facilities for gears individually. There is a new material to be tested for gears, a new type of bearing concept to be tried. So everything cannot be taken as a complete gearbox because it is very expensive. So individual testing to have more number of trials. So individual gears that will be tested. So subsystem testing, like lubrication system, it will be tested as a subsystem, and even uh, the extreme weather also, like cold chamber testing. Okay, later it is coming. Cold chamber testing at the extreme weather like Arctic, at -40-degree temperature, how the lubrication works, whether it is whether it will flow or not, like that kind of testing. All testing means highly accelerated life testing, that you are testing at the extreme loaded condition. You cannot, when the design is meant for 20 years, we cannot test for 20 years and check whether it is working or not. Correct. We need to test at accelerated condition. We need to simulate what will happen 20 years in a very short time, like in 1 month we need to decide. So that much capability we should have. And field testing means putting the gearbox on the wind turbine itself. So normally when there is a new design is involved, they will put the wind turbine in the wind turbine for 6 months, and they will observe continuously. They will take oil samples, and they will check visually by endoscope or something. Then there is a serial testing. Serial testing means 100% all gearboxes, whatever assembled in the manufacturing plant, is tested by running at the loaded condition for some time. Then it will be sent to the wind turbine, because in wind turbine if you send some with some defect, it will be a huge loss, because you need to stop the turbine, you need to arrange a lot of cranes for lifting, so it will take lot of time to, like months of time to dismantle completely and rerun the, until then you need to pay to the customer for the given downtime. So on maintenance perspective, periodic oil sampling, that you need to take occasionally the oil samples, so that any abnormal damage is there, even it will be sent to the laboratories for what are the particles. If there is a brass particle is there, okay, some brass relevant part is wearing, some iron particles, okay, whether it is a gear related, that steel particle or bearings or what kind of it is like that. So, and any water content is there or not, any other oxidation or anything is there, any additives, more additive is present, like that. A lot of analysis will be happening, and once in 5 years, I hope the oil will be changed and filter change will be there. In the, you can see where they are sitting at the very top. It's way less space. It's very difficult to work on that place. And visual and endoscopic inspection. Endoscopic inspection means like our medical field, they will put endoscope over inside our body to check the condition. Similar way, in wind turbine gearbox also, all gearboxes will be tested by endoscopes, that they will put the camera inside the gearbox to see the damages in the bearings and gears, and based on that they will take the decision to run as it is, or we need to stop the turbine. And up to our repair work, that some repairs can be taken above the turbine itself. On the top of the turbine there also some cranes will be there, local cranes will be there inside itself. It can carry certain amount of load, so they will take a repair on that. And sometimes if up tower is not possible, they need to exchange a gearbox, which will be too expensive. Yeah, that is my end of my presentation. Thank you for providing me this opportunity again. And I'd like to um, thank students and advise students also that this is a period you get more time. So invest your time and energy in developing your skills. Like our PM said, skill is something we gift ourselves, so it makes you unique. So you need to develop your skills, so that as a being whatever you are learning, get expertise on that, like learning POE, Unigraphics, CATIA. Like if you are taking on the CAD, means getting into all software is not on the surface level is not good. Get into one and expertise on that, and be open to learn lot of things. Just to keep your eyes open on the new trends whatever coming, like programming Python software is coming very good, lot of scope. And because of the Chinese problem, a lot of companies are coming. You will have good exposure to lot of companies will be, so good employment opportunity will be coming. I advise you to work more, to study more, to develop your skills. And thank you very much.
Okay, sure. So thank you so much, sir, for your enlightening presentation. We have
Thank you
some
very much.
queries from the participant side. The first question
Okay.
was from Prashant Padole. The question was, for increasing efficiency of wind turbine, shall we reduce the weight by using fiber materials? Thank you so much, sir, for your.
Just no, actually, inside the gearbox, except steel, even we are not allowing any plastics or fibers or anything. The weight of the parts, the torque present. So we cannot, for the given required strength properties, the fibers will not meet that required criteria. So still, okay, for efficiency improvements, we are going for very good surface toughness on the gears. In fact, 5 RZ gear finishes are maintained, and so that frictional losses will be less. And so the gear, the geometries, the macro geometries as well as the micro geometries, Very good. Whatever you are seeing on the macro geometry, the lot of crownings. There are too many micro geometries are involved in the gears. So on micro level, which is needed to improve having good load distribution and to have good efficiency. So yeah, that will be the solution. Not other
Okay,
than steel, we cannot allow it.
okay. Thank you, sir.
Yeah.
And another question from Mr. Surendra Pulivardi. The question was, how do we select GP value while designing wind turbine gearbox?
Geometrical pitch. Okay. In India and in metric system, actually module geometrical pitch is for inch system kind of thing. But it is mainly based on the torque level. So for the required torque level, already we will have a lot of size constraints from the customer. See, for gearbox will be designed by like a set of energy, these kind of people, and the wind turbine will be decided by the already the wind turbine supplier like Vestas, Siemens, Gamesa. These people will be already defined the boundary. Within this, you need to design the gearbox. This is our capacity requirement, and we will need to have the this boundary condition, this diameter, and this total length of the gearbox will be discussed. So we have already that condition. So we have a lot of software and internal calculation tools so that for the required torque level, what module will be best suitable? How much face width, that is the width of the gear teeth, can be taken for that gear width? So we go for maximum the standard module list available. We cannot go the like for example 18 module or 20 module, 19 module, like that, the integer number. We will not go for 18.1 module, 18.2 module, like that. We will not go the special model. We will have the standard cutters on the specific. We try to maximum try to use the standard the available module because the tools will be also available readily. We can try it very fast. Otherwise, we need to wait for tool manufacturing, which will again take 3-4 months. So that's this one. Based on the torque level and available tool, available experience. Suppose already we have 2 megawatts design already existing for which 17 module gear is used. Then we are getting 2.5 megawatts. Okay, we will maximum try to use whether the same 17 module can be used or not, or we will adjust the model proportionately. Next model we will go like that. If it is a first from fresh work, then we need to analyze a lot. If it is already some reference is available like earlier designs, then we will take reference from that and improve on that. Yeah.
Okay, sir. Okay. Same question. Another question from the same participant. The
Mhm.
question was, why can't we use or design a flexible epicyclic type to attain large values of GR value?
GR means gear ratio. What they mean? I
Yes,
don't
sir.
know.
You have
But
mentioned as GR value.
flexibility in planetary means just a minute. Flexibility in planetary means I don't understand. Only where the flexibility we can include is the the planet spins actually because of the high load, because of too much length of the components, the load distribution, the entire width of the components. Suppose the planet wheel is 300 millimeter face width is there. The entire 300 millimeter will not have mesh because of high load. The tooth also will get deflected. The tooth will not be straight. Suppose 18-degree is there because of high load, it will become 17.9 or 18.1 based on the load direction. So that much deflection will be there. So to have this, the planet, there are two conditions because we need good load distribution. Entire 300 should be in mesh during high load. Then uh, we can adjust by two parameters by considering the microgeometry, by considering the lead correction. Let us keep 18.1 degree first itself, so that during the high load, it will come to 18 degrees, so that the entire mesh, entire the face width will come in contact. Another one is actually the planet shaft, where the planet wheel is located. It will be having a flexing technology. It will be a flexible material, so that it will adjust when there are more than one planet in the same shaft. At the time 300 they will not have one planet. They will fit 150 millimeter one planet and another 150 millimeter one planet. And in the center, the shaft will be flexible enough. So during high load, the shaft will be flexible, so that the two planets will be in the entire face width will come in contact. Like that, flexibility to improve the load distribution of the planet. Uh, yeah, all other conditions needs to be rigid to take the load. More the flexibility, more the deflection. Correct. For the given target, if we give more flexible, then we need to, our system should be very stiff enough to take that load. Yeah, that is,
Okay. Thank you, sir.
yes.
So another question was from Abhinash Nayak. And the question was whether metallic wind blades can be substituted by fiber and plastic blades.
You need the existing itself, as I mentioned in the presentation, for 2 megawatts, the weight of the blade is one blade is almost 7 to 7.5 tons of weight. You can take that. What will happen in case of metallic blades? The weight will be too huge, and all these things will be taken by the gearbox, then generator and internal. All bearings needs to take that load. So metallic will increase the weight and cost. Existing is actually, it is not a complete fiber. It is mainly a wood based structure, and fiber reinforcements to increase the strength. It will be there. It is not a complete fiber blades. So fiber reinforcements and with some resins to give that flexibility. And the metallic is some metallic reinforcement maybe you can do, but it is again, it will be expensive, and more weight we are adding.
Okay. Thank you, sir.
Yeah.
The next question was from John Praveen. The question was what kind of material is used for gears in wind turbine gearbox?
It is almost all wind turbine manufacturers will use 18 chromium alloy steel with even automobile also, mainly for gears. It is uh, we can tell just alloy steel with 18 chromium content.
Okay, okay, sir. Thank you.
Yeah.
The next question was from Vishnu Das. The question was
Mm.
to get 1 megawatt electricity, how many windmill would be required? Or generally, one windmill produce how much electricity?
Depends on the capacity of the wind turbine. Suppose we have 2 megawatts. Like earlier, I was telling Siemens Gomez I introduced before 10 days, 3.4 megawatts. Yeah, one turbine is producing 3.4 megawatts. What it means, 3.4 megawatts means in 1 hour, how much megawatts it is producing. So in 1 hour, that one turbine produces 3.4 megawatts or 3,400 kilowatts it is producing. So that is one turbine.
Okay, okay, sir. The next question was from Mr. Ramesh Chand. The question was what is the minimum wind speed required to drive a windmill? And what is the minimum height of a windmill?
Uh, Minimum height we can, it differs from place to place based on the your surface structure. Before putting any windmill, they will study the landscapes, whether any buildings are there, any mountains are coming. It will become obstruction to the wind, and like why the people are going for offshore to put in the sea is there is no restriction actually. The wind will flow as easily, but not the ground. We will have lot of restriction, and normal they will keep at least 1.5 to 2 times the length of the blade, so that the blade should not blade should have sufficient gap from the ground. Whatever the blade length, they will keep 1 to 1.5 1.5 to 2 times the height of the tower. And another question you were asking, I forget. What is
The question
same
was,
question?
I repeat the question, what is the minimum wind speed
Ah,
required to drive a windmill?
yeah, minimum wind speed is like 5 meter per second. At least it needs to be there, so that it will start rotating. And maximum there will be for each turbine, they will provide the power curve. It is called cut-in wind speed. Cut-in wind speed, cut-out wind speed. Cut-in wind speed means this 5 meter per second. After that only it will start rotation. Then beyond 20 or 25 meter per second, the turbine will pitch the blade so that the blade will be in the direction. It will divert all the wind. It will not rotate. It will come to complete stop. Otherwise, it will more load will come to the blades and all other systems. So it will turn the blades so that all wind is directly passing the turbine. It will not try to rotate the blade will have such kind of aerofoil shape.
Okay,
Yeah,
okay, sir. Thank you. The
yeah, thank
next
you.
question was from Mohammed Marwan. The question was, how mechanical lubricator pump works when there is no electricity?
Yes, it is connected to the pump pinion will be connected to the one of the large wheels mainly in most of the condition. Like there are two big wheels are mounted, like low speed wheel. I have specified in the presentation, low speed wheel or intermediate speed wheel. Two big wheels will be there. This pump will have a smaller number of pinion at the front, so that it will mesh with that. When there is no current also, if the blade, because of the wind, if there is no lock is available, the blades will start, suppose some rotations, it rotated means, then once the blade is rotating, automatically it is connected to the shaft, the gearbox going to rotate. If the gear is rotating, automatically, because of this small pinion is having mesh with the pump, mechanical pumps at the same shaft, a pinion is mounted, pinion is meshing with the wheel. So this pinion will rotate more rotation, as it is a small number of smaller number of teeth. It will rotate more rotation, then pump will start rotation. There is a gear pump, actually mechanical pump is a gear pump. So it will pump the uh, percentage of oil to the critical bearings.
Okay,
No
sir. Thank you.
electricity is needed.
Another, okay,
Mm.
okay, okay, sir. Another question from the same participant. How initial torque is applied to the blade?
Initial torque, no, there is no initial torque is fixed. Only even if they are during starting of the turbine, if they are pitching the blade is sufficient. Pitching means even when we are traveling on the road, we can see some turbines, the blade will be blades, the position will be rotated in a direction, just aligning with the tower axis. It is just it is stopped at the stopped condition. They will pitch the blade so that wind will not try to rotate it. Uh, if we are during starting the turbine, they will release a lot of mechanical locks, pin lock also will be there for safety reason. They will release that pins, and they will just fix the blade. They will, once they start rotating that blades, that fixing the blades, automatically wind will push to rotate. No need of we need to drive it. The wind will push it and to start the rotation. Once it reaches that 5 meter per second, which is sufficient to start rotation. The torque, initial torque is given by the wind itself. We are not providing.
Okay, sir. Thank you.
Yeah,
The
yeah,
next question was from Tamil Kumaran. Uh,
yeah.
During storming conditions, which
Hmm.
controls the pitch and yaw motions?
You can see at the top of the even this also practically we can see why I am telling is while going on the road like that, this kind of things we can see from outside. At the top of the nozzle, there are two sensors will be there. One is anemometer, another one is wind vanes. Anemometer is to sense wind speed, so that in storming condition, like 25 meter per second, the wind is blowing means it will immediately sends a signal. There is a SCADA system inside the condition monitoring, whatever explained. So it will give the signal, okay, it is going to damage a turbine, so we need to pitch a blade like that. So it will start to pitch the blade so that it will bypass, try to bypass the wind, not work against the wind. And the wind vane, it will sense the direction of the wind. Okay, if it is coming, heavy wind is coming from this direction, we will turn in the other direction or towards. So wind vanes will there, it is working on the against the direction of the wind, sense the direction of the wind,
Okay,
and it
okay, sir.
the entire system is controlled by the SCADA, which is a nerve center of the complete wind turbine. Yeah.
Thank you, sir. The
Yes. Thank
next question was from Mr. Naha Kiran. What are the major defects occur in the gearbox?
I will tell on the bearings. Yeah, gears also there, but mainly on bearings, because I will tell any lubrication. Mainly the bearings will damage when there is a lubrication issue. There are different speeds at different stages. The low speed stage is at a very high torque is there. So when there is a high torque is there, you need a lubrication film thickness very high. But at the same time, if you coming to the output stage or last stage, the third parallel stage, it is rotating at a high speed but low load, where there is viscosity is not that much needed. Otherwise, it will create loss. So, but unfortunately, or we cannot keep each stage different lubrication. So we need to keep a same lubrication. So. So bearings, some mainly on the bearings, we will have failure modes
Okay, thank you, sir.
because of that film thickness
Then
related issues.
okay,
Yeah.
okay, sir. The next question was from Mr. Srinivasan.
Yes.
On high-speed rotation, when the sorry, on high-speed rotation during heavy wind flow, can we use the extra energy for some useful purpose other than energy generation by using suitable reduction mechanism?
Uh,
I will repeat the
Normally,
question, sir.
extra energy, it will not be, it will not rotate, it will maximum rotate the permissible speed only, because here we are not, we need to mainly focus on the plates RPM. Plates RPM, it is too much weight, it creates more load. So we need to limit that. It is mainly the entire turbine, everything is controlled by limited by load coming on. So more the speed, more load will come, and more load needs to be taken by the entire tower nozzle. This bearings related things, bearings mainly failure will happen. So uh, there is no extra energy. Whatever the complete energy will be. So maximum permissible rotation will be the whatever the speed rotated by the blades will be delivered by the gearbox also will transmit, and the entire this one will be converted into electrical energy. Uh, so already we have the bypass system like mechanical pumps. We are having a PTO, we call power takeoff. Like we are taking some power from the gearbox to drive the pump, like an additional one pump. All other energies, the gearbox is working at 97 percentage of efficiency. Only 3 percentage some efficiency losses will be there in terms of heat losses. Um, so uh, the we are not wasting any energy. I mean,
Okay, thank you, sir. And
yeah.
the last query was from Anbu Arasan.
Mm.
How does wind power affect peak load?
Uh, I'm not sure actually about the question. Wind power affects the peak loads. Peak load on the general electricity requirement in our domestic or industrial this consumption means. I may not be aware of it because it is coming to the electrical this one. So I'm not that much familiar with the grid management, that electricity management. I didn't note anything on that. Yeah,
Okay.
sorry for that. Yeah.
So, okay, sir, no problem. Thank you so much, sir. So
Yes.
once again, I want to thank you for the wonderful session, sir. And the
Okay.
way you
Thank
have
you.
clarified for all the queries, it was really enlightening. So thank you so much, sir.
Yes. Yeah. Thank you. Thank you for giving me this opportunity. Like, thank you and the entire management for providing, and it is a very good opportunity. And, thank you for all. Yeah. Bye.
Greetings to all of you. I feel honored and privileged in getting this opportunity to propose the vote of thanks on this special occasion. First and foremost, I thank the Almighty for making this event possible. On behalf of FXCC, I would like to extend my sincere gratitude to the Honorable Speaker, Mr. Sendilnathan Pichandi, Manager R&D, Siemens Gamesa, Renewable Energy, Bangalore, for accepting our invitation in his busy schedule and delivering such an informative lecture on this topic on understanding Windmill Gearbox. This exclusive session on Windmill Gearbox will kindle our desire to learn more. I extend my heartfelt thanks to the management, respected General Manager Development Dr. K. Jayakumar sir, and our beloved Principal Dr. V. Venmurugan sir for their moral support and tremendous guidance in conducting such a productive program. Finally, I would like to place on record my sincere gratitude to Dr. Joe Patrick sir, the head of the department, Dr. Jinatul Farida Abdul Ghani ma'am, Dr. I. Nidhi Manikam sir, Mr. Satish Kumar sir, Mr. Ram Kumar, and all our colleagues. Without their help and guidance, the program would not have been a grand success. Special thanks to our student Mr. Jason for his web screening support. This webinar was made successful only because of well-wishers, followers and participants of this event. Once again, I thank one and all. Stay home, stay safe.